Hello everyone. In this question we are asked to find the integral of x raised to the power 8 minus x square whole thing divided upon by the product of x raised to the power 12 plus 3x raised to the power 6 plus 1 times the inverse tangent of x cube plus 1 upon x cube. Okay, so you see we are given two algebraic functions in the fraction. So this is a rational algebraic function and we are given an extra trigonometric or inverse trigonometric function in the denominator. Okay, so these two are rational algebraic functions, right? But this is a trigonometric functions. So while trying to solve this, if I just isolate this part first, okay, that is if I rewrite it like 1 upon say tan inverse x cube plus 1 upon x cube separately, and I keep the other part separately as x raised to the power 8 minus x squared divided upon by x to the power 12 plus 3x to the power 6 plus 1. Okay, so I rewrite it like this in the first step. Now you see I don't think there is uh, any advantage in taking any substitution from this part. Okay, if we try using substitution on this trigonometric part, I think we might be able to do something. Okay, because if you do the derivative of this tan inverse function, you get 1 upon 1 plus x square, right? So this x square part might come handy in this right hand part, okay, in this algebraic part. Okay, so let us start with that. So I'm taking u equal to, I'm taking this entire thing, okay, I'm taking this entire thing as my u, tan inverse of x cube plus 1 upon x cube. Okay, so du will become, the derivative of tan inverse function is 1 upon 1 plus x square, right? It will be 1 upon 1 plus, and x is our this entire thing, right? This x cube plus 1 upon x cube. So this becomes x cube plus 1 upon x cube whole square. Okay, this is the derivative of tan inverse x, and our x is this x cube plus 1 upon x cube. Now according to chain rule, after this 1 upon 1 plus x squared, you also need to do the derivative of this part, right, of this argument itself. So on applying chain rule, the derivative of this argument x cube, derivative of x cube is 3x square, and this is basically x to the power minus 3, right? So the derivative of x to the power minus 3 is minus 3 upon x to the power 4, okay, times dx. Okay, so this is the entire du value. Okay, so let us further simplify it. Okay, so if we take 3 common in the numerator here, we have 3, and if we take LCM, we get x to the power 6 minus, this will become 1, right, upon x to the power 4 divided upon by 1 plus, if we expand this whole square, this is a plus b whole square, right? So on expanding this, we get x to the power 6 plus the 2ab term will be 2 times x cube times 1 upon x cube. So this a and b will cancel each other, right? So this will be just 2 plus b square, which is 1 upon x to the power 6, right, times dx. Okay, so again further simplifying it, we get du will be equal to this, on opening this bracket, this will become x to the power 6 plus 1 plus 2 will become 3 upon plus 1 upon x to the power 6, right? And the numerator is kept as it is for this step. Okay, x to the power 6 minus 1 divided upon by x to the power 4 dx. Okay, so again in the denominator, if I now again take the LCM, so this will become x to the power 6 times x to the power 6 will become x to the power 12, right? Then this will be 3 x to the power 6 plus 1 whole thing divided by x to the power 6, and in the numerator we have 3 times x to the power 6 minus 1 divided by x to the power 4, right? This is multiplied by dx. Okay, so now see, this is x to the power 4 here and this is x to the power 6 here. Okay, so I can cancel these two terms. If I cancel it, an x square will be left here. Okay, so this x square will go to the numerator in the next step. Okay, so we get du will be equal to 3 times, if you multiply x square with this x to the power 6 minus 1, we get x to the power 8 minus x square divided upon by x to the power 12 plus 3x to the power 6 plus 1 times dx, right? So now you see this is the value of du, our du value, right? Now you see this is very similar to this. I think this is exactly similar, right? X to the power 8 minus x square divided upon by x to the power 12 plus 3 x to the power 6 plus 1 times dx, right? This is exactly similar to that, except we have an extra 3 here. So in order to make them equal, we just divide both sides by 3, right? So we get du upon 3 is equal to x to the power 8 minus x square by x to the power 12 plus 3 x to the power 6 plus 1 times dx. Okay, so therefore the original integral, which was x to the power 8 minus x square divided by x to the power 12 plus 3 x to the power 6 plus 1 times tan inverse of x cube plus 1 upon x cube dx. Basically this now modifies to, we have isolated this part, so this is just 1 upon u. Okay, this is just 1 upon u times the remaining part x to the power 8 minus this remaining part, this is nothing but du upon 3, right? So this becomes du upon 3. So you see this integral has now simplified very much. It has simplified a lot. Okay, so now you just take the constant outside 1 upon 3 and this becomes du upon u. So this is just basically 1 upon 3 times ln mod u plus c. Okay, so this becomes 1 by 3 times ln mod of, our u was tan inverse x cube plus 1 by x cube plus c. So now you can just apply the properties of logarithm here and you can take this 1 upon 3 to the power. Okay, so the answer now becomes ln of mod tan inverse x cube plus 1 upon x cube whole thing raised to the power 1/3. Okay, plus c. So this is the required answer here. In the original question, all of the 4 options had this ln tan inverse this argument inside. Okay, the differences were in this power. Okay, in the 4 options the powers were given differently. So I solved it as a subjective question, but in the exam it was very easy to do this first step, right? You just needed to isolate this, then you needed to do the u substitution for tan inverse. Okay, so in the question exam, if you have the options, it actually makes the questions easier sometimes. Okay, so this was very easy to do. If you had the options, you know what substitution to do. Okay, so this was the required process used. This was a very easy integral, considered everything considered. Okay, so this is the required answer. If there are any doubts, you can highlight in the comments. Okay, so this is it. Thank you for watching.